Good evening, ma'am.
Yes, good evening. We're going to start the session. Please wait for 2-3 minutes. I'm waiting for 2-3 more students, then I will start the session.
Yes, ma'am.
Okay, let's start the session. So, this is, I think the PPT is visible, right? So, here we are going to start the session of week 2 microsensor implantable devices and rodent surgeries for biomedical applications. And I'm Arpita Biswas, a PhD scholar from IIT Jodhpur in electrical engineering department. So this is more details about me. So in this session we are going to discuss about some MCQ question, and here you can unmute yourself and directly say the answer. So this is the question number 1. So we are going to discuss about total 30 to 34 question, and if you have any doubt further also you can directly mail me. So in the next session also we can discuss if you have more doubts. So this is the first question. Which among of the following is not a applicable of BCI based experiment? So first option is epilepsy screening. Second is the deficit screening. Third is the sleep quality assessment and improvement. And fourth is the coma recovery index quantification. And fourth is all of the above. So please go through the question carefully, take your time, and then try to give the right answer.
Ma'am, one more time, ma'am. I can't understand. Question. One more
Actually,
time.
here you have to first you have to go through the lecture of I think Professor Hardik J. Pandya and one more professor is there, and they have shared the lecture video with you. So you have to go through the lecture video, and then here we can discuss about if you have any doubt. So here I am practicing some of the MCQ question, and it can also help you in your exams also. Okay.
Yes, ma'am.
So if you don't know the answer, it is not any problem, but at least you can try here what is the right answer. Okay.
Okay.
So take your time and at least try, then I will solve it.
Ma'am, but I didn't watch that previous video because I am first
Because
class.
then it is little bit difficult for you and also me, na? Is it because
Okay.
one more I think this is the week 2 session, and week 1 I have already taught. And at first it is your responsibility that you have to go
Yes,
through
ma'am.
the lecture video, because here only we are going to solve the problem if you are facing any difficulty you are understanding the lecture videos. That's why I have taken this question from the lecture, and here I'm again like discussing it. Okay. So
Yes, ma'am.
okay, if you don't know the answer, it is not any big issue, but you can also hear here what is the right answer, and what is this like courses here. Okay.
Yes, ma'am.
So here is the right answer is all of the above. So I'm just a minute. Yes. So see here the what is the question? Which among of the following is not an application of BCI based experiment? So here the right answer is all of the above. So,
Yes, ma'am.
so next we are moving towards the question number two. So if you go through the lecture, you can better understand what I am trying to say here, because all the question I have taken from the lecture video. Okay. So from the next week, you at first you will go through the lectures, like week 3 lectures. Then you come here and you can discuss your problem also here, or you can directly mail me. Okay.
Yes, ma'am.
So this is the question number two. Select the correct order of layer that cover the brain from outside inward. First option is scalp, then a skull, then pia, then dura, then arachnoid, then cerebral cortex. And the second option is the skull, dura, a skull and arachnoid, pia, then cerebral cortex. This is the layer when we are going for the deep braining, na. In that time, this is the layer how you can go from outside to inwards. Okay, so you have to find out the correct option by which after the which layer is present. Okay, this is the
Scalp,
question.
dura, pia, arconite, pia.
Which option?
Uh, I don't know. First option, I think so, ma'am. Scalp, dura, arconite, and next into the midbrain, there will be a pia meter.
Any other students? What is the right answer here? I think two, three more students is here. So, Shushmita, what is the right answer here? Take your time. At first, take your time. Go through the question carefully. Then try to solve the right answer.
Ma'am, C would be the right answer.
Can you please explain
C.
one by one?
Scalp, then
Hmm.
skull,
Hmm.
durameter,
Hmm.
cerebral cortex, arachnoid, and pia.
Is it the right option? Or arachnoid, then pia, then cerebral cortex? You can cross check it. Okay, the right option is option D, scalp, skull, dura, arachnoid, pia, then cerebral cortex. So you can also cross check the answer. Okay.
Yes.
So next, this is the question number 3. What is the EEG lab? So first is the hardware prototype to conduct the EEG experiment. Second is the hardware prototype in with 8 electrode for free running EEG experiments. Third is the software platform for EEG analysis. And fourth is the EEG dataset with n equal to 100 subjects. So carefully go through the question. Then try to find out the right answer. So this type of question will come into your exam also. That's why my personal suggestion is at first go through the lecture, then come here. We are going to discuss about 30 to 35 question, and it will help in your exam also.
Yes, ma'am.
So find out the right option. And there is no hurry. You take your time and then try. So any guess what is the right option? So the right option is option C, software platform for easy analysis. Okay. So next question is, which among of the following is not a thin film physical vapor deposition technique? So have you heard of the word physical vapor deposition technique? What do you understand by this technique? Have you heard about this physical vapor technique? Anyone?
No, ma'am.
Shushmita? What is physical vapor deposition technique? See, physical vapor deposition technique is a deposition technique where a thin film like structure is deposited on the sample. Okay, So there are three types of deposition techniques are present, like thermal evaporation system, sputtering, e-beam, etc. So DRI is the deep reactive ion etching process. So this is the totally different process. So what happened in this, can anyone explain what the thermal, what is the basic difference between this thermal evaporation, sputtering and e-beam evaporation? Shushmita or I think one more student, what is his name? Shaktivel. Can you explain a little bit about you do you know about the thermal evaporation? What is sputtering and what is e-beam evaporation system? Hello. Any idea about this deposition technique? See. See what happened in thermal evaporation system. There is a chamber is present. Like the material is like here is the sample holder. Like where you want to deposit some material, and here is the sample. Like there is a board, and here is the material. Okay, the like boat holder is there, and here is the sample, like this is the sample, and here you want to deposit this material. So you pass a high voltage of current here, and it is melted, this material is melting, and then it start to evaporate, and it is deposited on the sample. So this process is called the thermal evaporation technique. Okay, and what happened in the sputtering system, it is also a closed chamber. This is the sputtering, and here is the target. Here is anode and cathode is present, and here is your sample where you want to deposit this material, and here is your material, like aluminium, gold, whatever you want to deposit, here it is. So what you have done, there is a argon, the bombardment of the argon ion. Okay, so it is bombarded on this material, and some of the material is deposited on the sample. Okay, it is in the like the closed chamber. Okay, and here is the argon bombard is there. So plasma create, and then the argon bombard on the target, and it is deposited on the sample. So this is called the sputtering system. Okay, and next is the e-beam evaporation system. In the word e-beam, here you can understand the e-beam is used to evaporate some material, and then it is deposited on the sample. Here is your sample. Okay, and okay, and here is your material, and you are using some e-beam, and it is heated this material. Here the e-beam is going, and
Ma'am, screen
yes.
share is not visible, ma'am.
um Sushmita, my screen is visible or not? Because I can see my screen is visible.
Yes, ma'am, visible.
So please
Oh,
connect your network. I think it is,
okay, ma'am. Okay, ma'am.
or you can rejoin. Okay.
Yes, ma'am. I'll check, ma'am.
Okay. So I'm waiting for you. You can rejoin.
Ma'am, please explain about the DRIE also.
Okay. Okay.
Yes, ma'am. Now it's visible.
Little bit I can give the idea, then one more class I can also put some picture of the DRI process or e-beam evaporation or sputtering. Okay, here I am going to give
Okay.
some little bit idea. So in e-beam evaporation technique, here the e-beam is used to heated up this material, and then it start to evaporate, and it is deposited on the material. So this is the basic difference. Here you are flowing some high voltage of current, and then it is heated this heated this material, and then it is deposited on the sample. This is called the thermal evaporation technique. And in sputtering, the argon bombardment is there, so it is directly on the sample, like whatever you want to deposit. and then it some of the part of the some nano portion of this material is deposited on the sample. So this is the sputtering. And in e-beam evaporation technique, here e-beam is used to heat up this material, and then it is started to deposit on the material. So this is the basic difference between this PBD technique. A deep reactive ion etching. Have you heard about this etching word, where we want to use this etching process? Do you have any little bit idea what is etching? Hello, Shushmita, and one more student I think is there. Have you heard about the etching process?
Heard, ma'am, but don't remember.
Actually, etching is a process which removes some of the particle or some portion. Okay. Actually, basically, we are using the etching process in the photolithography process. So, if you want to some a little bit idea, I'm going to give about the photolithography. Actually, photolithography is a pattern transferring process. Okay, so there is a pattern in the mask. Later also I will give the clear idea about what is photolithography, but here I am going to give some little bit idea. So this is a pattern transferring process. In the marks there is a some pattern is there. So what we want, this pattern is transfer on our sample, like where we at first we have deposited the material, and then I want to keep some of the portion, like we if you want to pattern some ID pattern or some electrode and electrode, like source and drain and gate. So some portion of the material I will keep, and some portion of the material I want to etch out, like remove, and this is called the etching. So what we go, at first we go through some of the UV exposure, then we go for the development process, and after the development process we go for the etching process. So whatever portion is covered with the covered, and with this portion will keep, and the remaining portion when we are agent, different of agent we have used, and this portion is gone. Okay, so this is called the etching. So deep reactive ion etching means removal of the portion, like here is the structure. Okay, this is the structure. Now I want to etch middle of this portion, like this type of a structure I want, like in the middle there is like some portion is removed. So in that case, if you want the etching like this type of structure, deep reactive ion etching, from the word what you are getting, this deep reactive ion etching. So see, here is some reaction is happening, and it is the dry process. Okay, they are not using the chemical wet chemicals. So this is the dry process, and some reaction is happening, and ion etching, so some ions bombarded here, and this removed this portion. Okay, some ion is bombarded and some portion of the material is removed, it's gone. Some here is the reaction is happening, and then it is gone. So this is called the deep reactive ion etching. So it is a little bit idea I am going to give. Now what is the etching process, what is DRI, like it is a dry process, dry etching process. Okay, so some ion are bombarded and it's cleaning or removing some of the material. So it is called the deep reactive ion etching. And what about this, the thermal evaporation on a sputtering, and what about the e-beam evaporation? This is a deposition process. Some of the material whatever we want, this we want to deposit somewhere of the sample, so this is called the deposition process. But etching is a totally different process. What we want here, removing some of the material. Okay, so this deposited material we want to remove some portion, this is called the etching. So is this clear? Hello. Yes,
Yes,
do you
ma'am.
have any other question, Shushmita, I think?
Ma'am, the purpose of itching is to for the designing purpose only.
Yes, here we use this
Okay.
etching process for the designing purpose. Like here you can see in the mask, here this type of ID pattern is there. Like this, here you can see like this portion. This is the ID pattern, and this is a source and drain. Okay, and here is the ID. Like here is the pad is present. Like So what we have done, at first we have deposited in the whole area, we have deposited the gold, chrome, whatever we want, chrome, gold and aluminum, whatever we want. But this pattern we want, so only this portion I will take and other portion I will remove. Okay, so this removing process called etching. So there are different type of etching processes present, like wet chemical etching, dry chemical etching. Okay, so this is called the etching. Any other question? Hello. So can I go for the next question?
Yes.
So this is the question number 5. Consider the following two statements about the E-beam evaporation and select the correct option. First is the E-beam is a CVD method, and second a statement is E-beam is is specifically useful for high temperature materials and ceramics. So here the option is both S1 and S2 are correct. Then second option is both S1 and S2 is incorrect. Third is only S1 is correct, and fourth only S2 is correct. So please go through the statement carefully and then try to find out the right answer. Have you heard about the CVD technique? What is CVD?
It's chemical vapor deposition.
Can you give the little bit idea how this CVD technique is take place, like how the process is going on? Little bit idea. What happened in CVD process? Take your time, but try. If you have any idea about the CVD process, what happened in CVD, how it's work, what is the basic principle of the CVD?
Ma'am, a even layer of solids is deposited in this method.
Okay. Any anything all? See. And now I'm going to discuss about the CVD basic principle. Like this is the three zone CVD system. Okay. This is the first zone. Just see the little bit about the CVD. When we are going to discuss here the CVD process, at first you have to know about the CVD process, like what happened there and why it is different from the E-beam. Because at first we have discussed about the PVD process, like E-beam evaporation and thermal evaporation and E-beam and also the sputtering system. And now we are here for the chemical vapor deposition. So what is the basic difference between this PVD and CVD technique? Okay, so here is the first zone, second zone and third zone, and we can control this zone temperature, different zone temperature we can control. So we have, like here we want to deposit some of the material by using the chemical vapor deposition. See, chemical vapor deposition, like chemically some chemicals chemical reaction is happen, and then it forms some material and it deposited on the sample. Okay, so here like you have taken one silicon dioxide wafer, and first zone, like here if you want to deposit some MOS2, so here you have taken some sulfur. Okay, and here in the second zone you have taken the MO3 powder, and it is in the powder form. Okay, MO3, and it is in atmospheric CVD. So you have set it some temperature here, like whatever temperature you want to give, and some random temperature like 800 or 900 degree temperature you have given here. So and this is the melting or evaporation temperature of the sulfur, and this is like near about the melting or evaporation temperature of the MO3. So what, when I am giving this much temperature in this zone, what happened, this powder will start to melt and it will start to evaporate. Okay, and this also evaporate, and this both chemically react to each other. Okay, and form the new material, and like MOS2, the MO3 and sulfur reacts and it's formed the MOS2, and it's finally deposited. And here some carrier gas is present, like argon gas we can use. This argon gas is flowing from it, and then this MOS2 is deposited on the sample. Now we can get the little bit idea the what is the difference. Where in the PVD technique some electric current we are giving to heated up the material, and also electric beam we have used to heat it up the material, and then it will start to evaporate. And also sputtering, the argon bombarded here directly, and then some of the nanoparticle of this material is going to deposit on the sample. But in the chemical vapor deposition, what happened here, some chemical in the powder format is, and it is the example of the atmospheric pressure CVD. Like atmospheric pressure, in atmospheric pressure the reaction is going on. And also there are different type of CVD processes present, like low pressure, where we have used the low pressure CVD process, and P the plasma enhance also in low temperature we can use. Okay, so what happened, it here we are taking some chemicals, and also we have heated up. So we have given some temperature here, and it start to evaporate, and and there is a chemical reaction is happen. And after the chemical reaction some material is formed, there's some new material, and then it deposited on the sample. Okay, so you got some idea about the CVD. Is there any doubt? Hello.
No, I have.
Okay, so see the first option, E-beam is a CVD process. So what you have learned from here, E-beam is a CVD process or PVD process?
CVD process.
PVD process, yes. And what about the next? E-beam is especially useful for high temperature material and ceramics. Is it correct or wrong? Yes, this option is right, because in E-beam also we have used the E-beam and is heated up, and then it start to evaporate, then it is deposited on the sample. Of course, when it start to evaporate, so it's required high temperature, right?
Yes, ma'am.
So which option is the right option?
Option D.
Option D.
A. A.
Yes. So this is the next question, question number 6. So the first statement is the physical vapor deposition is also called the vacuum deposition, and the second option is shadowing is one of the key challenges for PVD. So what is the right option here? See, I have already told that in physical vapor deposition, a closed chamber, you have to do all the process. Okay, so it is in control environment, and under bombardment, whatever you are doing, you are giving some current to heat it up, or E-beam you are using. All this process is in the control environment. So we require the vacuum. And also shadowing also is one of the key challenges, because sometimes the shadowing effect there in the next class also I can give more details about the shadowing. You can also in it also check. So this shadowing effect also the challenges for the PVD techniques. Okay, that's why the right option is option A, both S1 and S2. So this is the question number 7. Identify the incorrect pair for conventional medical technology. First is the dorsal is the connected with the frontal part. Second is the anterior is front, and next is the posterior is back, and fourth one is the proximal is the towards the body. So what is the right option? Option A. Okay. Anyone else? What is the right option?
A, ma'am.
Yes. Option A is the right option. Dorsal is connected with the frontal part. And next is the question number 8. Which among of the following is not the correct for deep brain simulation? First is the DBS helps in treating the movement disorder. Second, DBS requires the simulation as well as the acquisition of electrical signal associated with the specific brain region. Third is the DBS is a non-invasive method. Fourth is the rodent models for DBS target are well known. So which one is the right option? Have you idea about the invasive or non-invasive? Can you little bit explain here what is invasive process and what is non-invasive process? So we can get about.
Invasive,
Hmm,
invasive is inside the skull or a skin. Non-invasive is near the skin and non-contact with the body.
okay. Shushmita, I think you can give also if you have any idea about the invasive, non-invasive.
I mean, invasive involves means like open heart surgery,
Hmm.
and EEG can be example of non-invasive
Okay.
catheter use of slight invasive.
It means if you are doing something in your body, inside your body, it is called invasive, right? And if you are doing something outside of your body, if you're something, then it is called non-invasive. And here is the question is the deep brain simulation, it is invasive or non-invasive?
Invasive.
Invasive.
Okay, so which option is not correct here?
See, ma'am.
Option C, like
Okay.
DBS is a non-invasive method. So next question is which among the following technique has the best temporal resolution? MRI, NIRS, PT or SEEG? And this question directly I have taken from the lecture video. So you have to go through the lecture first, so you know about the full form of this techniques, I think, and what is the resolution or what is the temporal resolution. So do you know about the right option or I will give any idea? The best temporal resolution. So right option is option D, SEG. Okay.
EG.
Okay. And this is the question number 10. Which among of the following is an invasive neural investigation? EEG, MEG, SEEG or MRI? In is an invasive neural investigation. Invasive
EG.
SEG.
SEG. Yes. This is the question number 11. What does PVD stand for the context of neural implant fabrication? I have already discussed what is the full form of the PVD. This is the little bit short type of question. What is the full form of PVD?
Physical vapor deposition.
Okay, so option A is the right option, right? So this is the question number 12. Which of the following is not a common PVD technique? Sputtering, electron beam, chemical vapor, or thermal? And this is the recall of the, whatever I have taught this 37 minute. If you carefully listen, then you can give the answer.
Electron beam evaporation.
Is not a PVD technique. I have taught
Oh,
about the PVD technique already in this session. So go, take your time, but at least try. It is not a common PVD technique. If you can see the carefully the answer, you can give the option. You have to carefully see.
Is it chemical vapor.
Yes, chemical. It is totally different thing. PVD technique, the sputtering, E-beam, and thermal evaporation, and chemical vapor deposition is totally different thing. So the right option is option C. That's why I have taken this question two times. What at first I have taught, and then I have again question from it. Okay. This is a question number 13. What is the primary purpose of a PVD in neural implant fabrication? First, to deposit thin film for electrical and biological compatibility. Second, to etch away unwanted material. C, to create a bulk implant. Or D, to enhance the material property only. Take your time, but please try. This is also a easy question.
Ma'am, A.
Can you little bit explain? Explain about these options. Why not the others? Other option is the right option. Can you little bit explain?
Ma'am, PVT produces uniform films also,
Hmm.
plus made up of biological compatible materials, so
Hmm.
least reactive
Hmm.
with the biological tissues.
Okay. And what about the option B, C, and D? What I have taught, etch away unwanted material or removing material. What is it called? Which process it is?
PVD.
Etching. Etch away
Oh,
unwanted
Etching.
material or removing its means it's etching, so it is not part of the PVD. Okay. Then to create a bulk implant, no, this is not also the part of the PVD. Thin film type of material we have deposited using the PVD technique. Okay. And then what about the option D, to enhance the mechanical properties only? No, not only mechanical properties. Okay. So the right option is option A. Good. And this is the question number 14. Which material is commonly used for electrode coating in neural implant via PVD? First titanium, second gold, then platinum, and option D is all of the above. So, which material is commonly used for electrode coating? Okay, I think two, three more students is here. Shaktivel, what is the right answer?
titanium.
And what about the gold and platinum?
It's not because the titanium is commonly used for every implants, I think, rather than the gold and platinum.
No, the right option is all of the above. Titanium,
Okay.
gold, platinum, all you can use for the electrode coating. Okay. In our lab
Okay.
also we sometime we use the gold, chrome gold, and sometime we use the platinum, and sometimes the titanium. It depends on the material also. It depends. Okay. So all of the above is the right option. So this is the question number 15. What is
Ma'am,
the
excuse me, ma'am.
yes?
Ma'am, does they cause any cost changes?
Yes,
These
I
materials, three
think
materials.
yes, you know already, na platinum is more costly, I think, of gold. But in
Okay,
some
ma'am.
cases, some material, if you are using the gold, I think the properly contact is not formed. This type of, then there is different type of issue is there. Like directly, if you deposit gold, na, in that case also we can face the issue. Like it is not adhesive. Okay, so what happened in the gold deposition, like here is the like thin film is there, like MOS2 or something else is there, and we want to deposit some contact on the MOS2. So what we done here, first we have deposited some of the some nanometer range of the uh, chrome. Okay. And then we deposit, and it is little bit about the 30 nanometer, like 30 nanometer of chrome we deposit first, and then 210 210 nanometer of the gold we deposit. And this little bit chromium layer, why we need? To increase the adhesion. Okay. Because sometimes the adhesion is the more problem. And also the if we directly use the gold, it can diffuse on the material. It is diffusive. Okay, it can diffuse on the material, but we don't want this type. We only want to make the contact. So what we have done here, a little bit 30 nanometer, you can see, imagine 30 nanometer. You can also in the uh, in the naked eye, you can't see in the 30 nanometer of the growth of the chromium layer. And then we have deposited the 210 or 250 nanometer of the gold. So this, that's why the chromium layer is we have used. So first is the increase the addition and also stop the diffusion of the gold. Okay, this type of the different type of problem is there. That's why based on the material and deposition technique, we use this sometime titanium, sometime golden and platinum. So these three are commonly used for the electrode coating. Okay, so we move to the question number 15. What is the main advantage of the sputtering over the thermal evaporation? First is the higher deposition rate, second is the better adhesion and uniformity, third is the lower processing temperature, and fourth is the less energy consumption. Any Shaktivel, what is the right answer? Take your time, there is no hurry. And also, I think half of the question we have covered. What is the right answer? Shaktivel, what is the right answer? So the right answer is option B, better adhesion and uniformity. Okay, what is the main advantage of sputtering over the thermal evaporation? Why use the sputtering system? Better adhesion and uniformity. The question number 16. Which factor primarily determines the deposition rate in sputtering? First is that the atomic weight of the target material, second the pressure of the chamber, third the power applied to the target, and the fourth option is the distance between the target and substrate. So what is the right answer?
Atomic weight of the target material.
No.
Distance between the target and substrate, because small distance will determine a more rate.
No, the right option is the power applied to the target. Okay. The
Oh
factor
my.
primarily determine the deposition rate in sputtering is the power applied to the target. Because if you are giving the higher power, then it is increase the deposition rate. If you are giving the lower power, then it is slow the deposition rate. This is a question number 17. What role does the vacuum play in PVD processes? Prevent the oxidation and contamination, second the increase the deposition rate, third the reduce the cost of the fabrication, fourth act as a catalyst in deposition. So what is the right option?
B. Increase the deposition rate.
No.
Prevent the contamination.
No. Prevent the oxidation and contamination. Okay. Vacuum is required to prevent the oxidation and contamination. Next is the question number 18. The electron beam evaporation, what used to heat the source material? First is the infrared radiation, second high energy electron beam, third is a resistive heating element, fourth is a magnetic field.
High energy electron beam.
Yes, high
Correct.
energy electron beam. Yes, this is the right option. Next is the question number 19. Which of the following is a limitation of PVD for neural implant? First is the limited to high melting point material. Second is the poor film adhesion. Third is the high contamination risk. And fourth is the high temperature damage to substrate.
Check it.
So the right option is option D, high temperature damage to substrate. Okay.
Yes.
And this is the question number 21. Which gas is commonly used in the sputtering process for neural implant? First is the oxygen, second is the argon, third is the nitrogen, and the other option is the helium. So which gas is used commonly in the sputtering system?
Argon.
Okay.
Okay.
Yes, the right option is argon. I have already told the argon bombardment is there, like in the closed chamber. Here is the here is the material. The target is present. Here is a sample where you want to deposit the material, and here the argon bombardment or the target material, and then the nanoparticle of it is deposited on the substrate. Next is the question number 22. Which of the following affects film adhesion in PVD coating? Surface roughness, chamber pressure, substrate temperature, or all of the above? What is the
All
right
of the
option?
above.
Yes, all of the above is the right option. So next is the question number 23. Why is multi-layer deposition is used in the neural implant? First, to reduce the overall implant cost. Second, to improve the mechanical, electrical and biological properties. Third, to minimize the deposition time. Or fourth, to make implant thicker. So what is the right option?
To minimize the deposition time or make the implant thicker, two options.
No.
Oh,
Go through the question carefully. Take your time. Then try to give the right answer.
multi-layer deposition instead of neural implant. Option B.
Yes, to improve the mechanical, electrical, and biocompatibility properties. Good. Question number 24. Which part of the rodent brain is primarily responsible for motor control and coordinations? First is the cerebellum, then hippocampus, then thalamus, and over the hypothalamus. There is no hurry, you take your time. So, what is the right answer?
Hypothalamus.
No. The right answer is cerebellum. Option A is the right option. Then this is the question number 25. The hippocampus in rodent is mainly associated with which function? Sensory processing, memory and spatial navigation, hormone regulation, or motor control?
Hormone regulation.
B. Memory.
Yes, B. Memory and spatial navigation. Next is the which structure in the rodent brain plays a key role in regulating the emotion and fear responses? Amygdala, medulla, cerebral cortex, or corpus callosum?
Mana amygdala.
Yes,
Amygdala.
yes, amygdala. Next question is question number 27. The corpus callosum is rodent function to first regulate the circadian rhythms, and second option is the connect the two hemisphere to the brain, second is the control voluntary movement, and fourth option is the process olfactory signals.
Ma'am, B.
Okay.
Connect the two hemispheres.
Shaktivel, what is the right option?
Hemisphere, connecting the two hemisphere, which
Yes,
is connecting.
option B is the right answer. Good. Next is the question number 28. Which lobe of the rodent brain is primarily responsible for processing the visual information?
Occipital.
Occipital. Okay. Yes, the right option is option B, occipital. And next is what is the primary function of the thalamus in rodent neuroanatomy? Generating the reflex actions, relaying the sensory information to the cerebral cortex. Third is the controlling anatomic functions, and option D is the producing the cerebrospinal fluid.
Sensory information to the cerebral cortex.
B.
Yes, the B is the right option. Relaying the sensory information to the cerebral cortex. Then question number 30. Which region of the rodent brain is crucial for regulating the homeostasis, including the hunger and temperature control? So first option is the thalamus, then pons, then hypothalamus, and the basal ganglia. Which option is the right option? Take your time, there is no hurry,
Thalamus.
but I want the correct answer.
Okay. Hypothalamus.
Yes, the right answer is hypothalamus. The option C. So next move toward the question number 31. Which of the following structure is involved in voluntary movement and the part of the basal ganglia in rodents? First is the substantia nigra, and then the hippocampus, then amygdala, and fourth option is the cerebrum.
Ma'am, substantia nigra.
Yes, the right option is option A. Then this is a question number 32. Which sensory system is highly developed in rodent due to their reliance on smell? First is the visual system, then
Olfactory.
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 Auditory, and then vestibular system. Yes.
Olfactory.
Okay. Then the question number 33, which part of the rodent brainstem is responsible for the controlling basic anatomic functions such as heart rate and breathing? Pons, medulla oblongata, then midbrain and the cerebral cortex.
Means medulla oblongata.
Yes,
Breathing control.
the right option is option B. And the next question is question, this is the last question. Next we can little bit discuss about the photolithography process if you interested. 10 minute we can discuss. So this is the
Yes,
question
ma'am.
number 34. Which neural structure in rodent is often studied in its role in learning and memory consolidation? First option is the striatum, second is the hippocampus, then thalamus and the cerebrum. So which one is the right option?
Hippocampus.
Yes, the right option is the hippocampus. So here the question is over. Now I'm going to discuss little bit because we have the time. So 10 minutes we can discuss about the photolithography if you are interested. So can I discuss one by one the process, the photolithography? From the word photolithography, what do you can understand?
I'm related to some designing graph.
Yes, photo, PHOTO, photolithography. PHY. Okay, so photolithography, it's from this word you can relate the photons, light sources or something. Okay, so this is used to transfer some pattern. So see here the different type of mask we have used. The bright field mask and the dark field mask. Bright field mask means only this pattern is like covered. This portion is covered, and like this is the source and this is the drain. This type of structure is there, and in between if you want to add the gate also present, and all remaining portion is like the transparent, and only this portion, this two portion is like opaque. So in that case you can call it is the bright field mask. Okay, the bright field mask. And what about the dark field mask? All other portion are like opaque, the light can't pass. Only this portion is transparent. This electrode portion is transparent, light can pass. Yeah, all other portion is opaque, like this portion is opaque. So this is the maximum portion is like dark color. So this is called the dark field mask. So there are two type of mask. Now what we want, this gate source and drain we want to transfer from this mask to the device layer. Okay, so what we like do, first there is a sample like silicon dioxide sample is here, SiO2 sample. Then what we have done, we go for the deposition technique. Some material we deposit. If you go for the photolithography, like the chromium or gold we have deposited here. And which technique we use to deposit the material? Which technique? Hello. I have already taught now which technique I have used to deposit some material.
CVD,
Yes,
PVD.
PVD or CVD technique. In PVD, what type of techniques are present? Hmm? I have already taught there are three types of PVD technique is present. Which tell me. Thermal evaporation and another one
E-beam
Chemical,
E-beam and sputtering.
evaporation.
Yes,
electron.
yes, E-beam, sputtering and thermal evaporation. So using this technique, we have deposited the chrome gold. So this is the upper portion we can see from the side. Okay, so then what we have done, this pattern I want to transfer from this mask to here. So what we have done here, we go for the UV exposure. Like here is your sample, and here is the gold deposition, and also some like mask we have also used here. Like um, like the pattern is transferred from this mask and then it is transferred to that one. Some liquid is the liquid type of I can't now I can't recall the name. So here is the mask is present, this is the mask, and here is the UV light is present. So and here is the electrode design. So from the light UV exposure on this layer, this is the some photo like positive and negative. So first this layer is transferred to this like this is the light sensitive layer is present. In the next class I will discuss. Okay, so from here this layer is transferred on this layer, it is light sensitive, and after that we go for the development process. And go for the development process, like if we use this sorry, yes, this layer called the photoresist. So and also there are two type of photoresist, like negative photoresist and also the positive photoresist. Next class I will discuss about the different how the pattern is transferred. So next this type of mask is here, then the photoresist is there, and then below the deposited layer is present, and then this is the silicon wafer. Okay, and then we go for the development process. In the development process we dip this wafer into the solution, and what happen in there, some of the particle of the photoresist which is which is covered, like here directly the UV radiation is come. So whatever is covered, like this portion will if a dark field mask, so only this portion will remain, this portion will remain and another part will gone when we dip this wafer into the development solution. Okay, then this type of, like here you can see, here is a sample, I don't know how much you are getting. So this is the AU, and here the photoresist layer, only this electrode portion is present after the development process. And then we go for the etching process, like it also acts as a protective layer. And when you go for the yeah, etching process, this portion is protecting layer is present and this portion is not present, so it is directly etch out this portion, directly etch out. Different etchant we use in this case. Okay, so what happened after the etching process, this type of structure we get the sample, and then the electrode, and upper the electrode the photoresist is present, and here is the source and drain, and then photoresist. And what happened next, we dip this wafer into the acetone to remove this photoresist layer. So finally after dipping the acetone, we got this structure, this from here this mask to the device, this pattern is transferred. Here is the electrode and here is also the source and drain. Okay, so this is the like basic idea about the photolithography. So do you get it there, get it?
Yes,
Yes,
ma'am.
ma'am.
Okay, so up to this, here we are ending the session. Next class we will discuss. And if you have any doubt now, you can directly mail me. My mail ID is biswas.5 at the rate iitj.ac.in. You can directly mail me. So that particular topic also we can discuss in the next lecture. But first you have to go through the lecture video, like the weekly lecture video you have to go through. Then come here we are going to discuss about so 30 to 40 MCQ question, and that type of question will come in your exam also. Okay. And here using this MCQ we are also covering all the 3 to 4 lecture of 3 to 4 weekly lecture, and it will also help you. Okay. So first go through the lecture, then come here, and if you have again the problem you can directly mail me. So in the next class also I can some portion of this topic we can discuss there. Okay. Hello.
Yes, ma'am. Okay, ma'am.
Okay, so you
Okay,
can
ma'am.
leave. Okay.
Thank you.
And
Thank you, ma'am.
also I'm going to upload this lecture in my YouTube also, and also the PPT also I'm going to upload, so you can also further access it. Okay.
Yes, ma'am.
Okay, okay, thank you.
Thank you, ma'am.